So we know that the cross-tabC function is used to create cross-tabulations. It can also run a chi-square test of independence and generate some measure of association. Uh, you may also know that we can add a control variable to a uh, cross-tabulation to create a controlled cross-tabulation, which would produce cross-tabulations within each value of the control variable. And we can do that with our chi-square test and our measures of association as well. So let's stick with our example of concern for other races by party identification. And to add a control variable to this analysis, we would use the z variable, or the z argument, and set the value of the z argument equal to a variable that separates the observations into a relatively small number of categories. Um, I'll use gender here. So this would do a cross-tabulation of concern for other race concern by NES party identification controlling for gender of respondents. So I should get one cross-tabulation for males and another for females. And if we've done this right, it should give a chi-square test and a Somers-D measure of association within each value of the control variable. Let's see what we get. So our control cross-tabulation looks kind of a messy because it's breaking. I'm going to clean that up and then show a cleaned up version for you. I'm using the zlabs, ivlabs, dvlabs arguments to abbreviate somewhat the labels for the control variable, independent variable, and the dependent variable, and also reduce the digits to 1 to try to compact the table a bit. The lines are breaking, which makes it a bit hard to read. Um, they are still breaking somewhat, but I think we'll be able to fix it. So we'll look at the table real quick and then talk through quickly the chi-square test and the Somers-D statistics. So we have a controlled cross-tabulation, the relationship between party identification and concern for other races controlling for respondents' genders. You can see we have one cross-tabulation for males. This is on the left side of the controlled cross-tabulation. We've got the relationship between the independent variable and the dependent variable for males. And then on the right side, we have the same comparison, party identification by concern for other races for females. So it's a controlled analysis in two groups, and we can see how that varies and even see a little bit of the plotting of how the relationship varies, how the party effect as well as possibly a gender effect. We look at the chi-square tests for independence. What it's doing is actually doing it within each group to identify or test whether the relationship between party identification and concern for other races is significant for males and also whether it's significant for females. So it tells us that within males, the chi-square test statistic is 163 and 8 degrees of freedom, and the p-value is less than 0.05. And for females, similar results with a larger, even a larger chi-square test statistic of 231, and the p-value again is less than 0.05. So the relationship is statistically significant within each group. So we've seen the description. We know that it's statistically significant. How much of the variation does party identification explain? So we've got the Somers-D reported for each group. Now it's truncating it a bit because I put digits equal to 1. I'm going to run it with digits equal to 2 so we can see a bit more of the Somers-D statistic. Okay, so in both cases, for men and for women, there's a positive relationship between party identification and concern for other races based on the way the values are coded that we saw in the table. Then for males, the Somers-D statistic is 0.20, and for females, it's 0.22. So the independent variable is explaining about 20% of the variation among males and about 22% of the variation among females. So they're fairly comparable and fairly comparable to what it was overall, maybe slightly more explanatory power within the female group compared to the male group, but we're only talking about a 2% difference. But there is a statistically significant, relatively strong positive relationship between the variables, even controlling for another variable. So the relationship withstands controlled analysis. And if we're careful about it, we can use the cross-tabC function in one function call to do all that analysis at once. So I think it's a pretty good a good application of it and a powerful thing to do. It used to be in earlier versions of this book and what I've seen in other books that this analysis takes multiple lines of code, subsetting the data, then analyzing the subsets, and then sometimes applying separate functions to do the analysis based on the tables. Kind of worked hard to roll that all into one, so all that stuff that you might want to do, the test of statistical significance, the controlled analysis, the measures of association, can all be done at once. But when you're doing that, I just encourage you to take it one step at a time. Even though I'm pretty familiar with these functions now, even when I use them, I start with the basic cross-tabulation and then add optional arguments to it one at a time and checking my work as I go to see that executing correctly. And if you build it step by step, you will progress fairly far with it. So I hope you enjoy this video and using this cross-tabC function.